Hi everyone, so today we're going to be looking at 6.4, which is rates of change in a quadratic relation. So we're going to be able to looking at first difference and second difference from a table of values, and then we can use them to classify whether we're looking at a linear or quadratic equation. So our first differences, when we're looking at the first differences, we are looking at the y values that correspond to the executive x values. So when the first differences are going to be equal to one another, you have a linear equation. So, for example, here on the right, you can see that our first differences between our y-axes in this section here is all going to be positive 4. So that means it is linear. When we look at the second differences now, this is the differences between the first differences. So when the second differences are going to be equal to one another, then you have a quadratic relation. So these are our first differences, these are our second differences. So because the second differences are all the same and the first differences are not the same, then we have our quadratic relation. So we're going to look at a few examples here. We're going to look at the following relations to determine if they're linear or quadratic. So we have to calculate the first differences and the second differences. So we're going to calculate the first differences between the following table here. So they do 7 minus 5, they do 9 minus 7, oops, not 5. 9 minus 7, 11 minus 9, 13 minus 11, and we will see that it is 2 for all of these. So therefore, we don't have to do the second differences. So therefore, it is linear because our first differences are equal. Now let's do the next one to the right. Same sort of thing. Calculate the first differences. So 11 minus 18 is negative 7. Continue with the rest. We had negative 5, negative 3, and negative 1. So therefore, we have to go into the second differences. So in this case, we calculate the second differences between these. So negative 5 minus negative 7. Keep that in brackets. We'll get 2. Negative 3 minus negative 5. We'll get 2. And then negative 1. I don't know why I didn't put a negative. Negative 1 minus negative 3 will also give you 2. So therefore, quadratic. I'm going to write quad, so it is quadratic, okay? Because second differences are equal. Now let's try out this situation here. It's very important to note the power here. We need to find our y's. So what we have to do is plug in our x into the y equation. So therefore, we're going to be doing 3 bracket 0 to the power of 2 plus 2x minus 1, which we will get 0 plus 2 minus 1. I did make a little error here. There's another x, so therefore we have to plug 0 into this as well. And then 2 times 0 is just going to be 0, so we have to change our little answer here. Plus 0 minus 1 is going to be equal to negative 1. Let's do the next one. So 3, and then we plug in the 1 into the x. To the power of 2 plus 2, 1 minus 1. Break it up. We have 3. Okay. And then we have plus 2 minus 1 is equal to 4. So because this power of 2 is there, make sure you don't use it because we're looking at linear equations. Next, we have 3, 2, power of 2 plus 2, 2 minus 1. So make sure that you're plugging in. So 3, and then we have 4 plus 4 minus 1, and then 3 times 4, it's going to be 12, plus 4 minus 1 is going to be 13, not 13, 15, correction. And then this last one is going to be equal to 32. So we can see here, these are all our y's. Now we need to do our first differences among the following. So 4 minus negative 1 is going to be equal to 5. We have 15 minus 4 is going to be equal to 11. And we have 32 minus 15, that's going to be equal to 17. So our first differences are not. Then we do 11 minus 5 and 17 minus 11, and we get 6 and 6. So therefore, quadratic, because second differences equal. And then try the last one out. Plug them in. Therefore, you don't need to do your second. All right, so now notice the pattern in the cubes that are seen here. So here, if we look, it is 1 cube. If we look at these, it is 2. If we look at these, it is 3. If we look at these, this is 4. So now what is the next part of our sequence? Well, we could do our 4 first. And then we obviously need to add another row because we need to make it 5 to add on. And that is what it would look like. So our total here would be 5. So now we're going to complete the table to identify a relation. So it starts at 0. We know our side length was 1, 2, 3, 4, and we stopped at 5. And the number of cubes, if we looked at the first one, we had 1 cube. So that was the number of cubes. The next one, we had 4 on our face here. Okay, we had 4 on our face. The next after that on our face, we had 9, and then 16, and then 25. Now if we're going to look at the first differences between them, 1 minus 0 is going to be equal to 1. 4 minus 1 is going to be equal to 3. 9 minus 4 is equal to 5. 16 minus 9 is equal to 7. 25 minus 16 equals to 9. So therefore, non-linear. So we have to go to our second differences. So 3 minus 1 equals 2. 5 minus 3 equals 2. And then 7 minus 5, 2. 9 minus 7, 2. So therefore, it is quadratic. Now we have to make a scatter plot and show the curve of best fit. So what we're doing is we're just plot our x and y. So this was our x and this was our y. So we started at our 0 and 0. Then we had 1 and 1. We had 2 and 4. We had 3, 9. We had 4 and 16. It's gonna be somewhere up here. So make sure, obviously, it makes sense for when you go up by number. Mine obviously didn't make the most sense. Make sure you plot all the points. And then this is gonna be your line. And because it's quadratic, it's gonna be the same on the other side, right? So it's gonna go all the way up. Make sure it's equal on both sides. Mine was not. But when you do this, make sure it's equal and you draw a scattered line or dashed line here. Because of that, it's not a real line right now. We're just assuming of what it's going to be, okay? Make sure when you draw your graph out, you label it. So this was gonna be the side length. And this was gonna be the number of cubes. And this is your y and this is your x, so make sure you label that. And then let's answer the following questions. Is the graph a parabola? Okay, well, based off of what our information was, it is half. Okay, half of a parabola, since you cannot have negative side lengths. So that's why we use the dashed line. What are the coordinates of the vertex? Well, it's 0 and 0, because that's what it started at. And what is the equation of the axis of symmetry? It was 0. X is equal to 0. So could the line be used to model this data and explain why or why not? No, we cannot. And the reason for that is since the number of cubes is not going up by the same amount each time, then we can't use a line. Because if it was linear, then we could, but because it's not, we can't do that. And then the equation of the relation of y equals x squared, where x is the side length and y is the number of cubes. How many cubes are in the pattern? The side length is 7. So therefore, we're going to say let x equals 7. We're going to use the formula y equals x squared, and we're going to plug in 7 into where x was, and we will get y equals 49. So therefore, it will have 49 cubes. All right, let's do this example together, and then you're going to do the next one on your own. So it says here that a man dives from a cliff, and this cliff is going into the water, obviously, and the parabola of his flight is modeled by the equation as followed, where x is the time in seconds since jumping and y is the height above the water. Use Desmos.com to plot the graph and sketch the grid. So you are going to go on to Desmos.com and plot that graph. So you're going to write this equation exactly into Desmos.com. It's a fabulous website, and go there and you're going to plot it. Once you get that information, you see the graph on Desmos, then you're going to plot it on the table here. So we're going to label 1, 2, 3, 4, 5, 6, 7, 8, 9, because this is our time in seconds. The next is our height, because we're showing his, obviously, his dive. And we're going to go up 2, 4, 6, 8, 10, 14, 18, 22, 6, 8, 30. Okay, so based off of this information here, we can graph. And when we graph this, it says that the vertex was 2 and 32. It said that it hit the y-intercept, which is based off our graph at 24 and 0, and that it hit the ground, which is our zeros, at these 2, so it's -2 and 0. This is 6 and 0, and this is at 0 and 24, and this was 2 and 32. So if we were to graph this, we could graph the following. Obviously, make sure yours is perfect, not just guessed like mine. So it says, what are the x-intercepts and what is their meaning of the scenario? So our x-intercepts are -2 and 0, and our 6 and 0. So our -2 and 0, it doesn't make sense. And the reason for that is because you can't have the time be negative. You can't go back in time. So therefore, our 6 and 0 tells us it takes him 6 seconds to hit the ground or hit the water when he jumps. All right, what is the vertex? We know the vertex is 2 and 32. What is the maximum? Is that a maximum or a minimum? We know that this is the max. And what is the meaning of the scenario? So since it opens down, he reaches a max height of 32 meters after 2 seconds. Because he's jumping and then dives. Now, what is the y-intercept? So that's where it hits the y-axis, is 0 and 24. The reason for that, so that is our time, which is 0. And then, so he starts at a height of 24 meters. And then he jumps from there, okay? Using the graph, what is the approximate height of the man after 4.5 seconds? So you're gonna take this information and kind of go 4.5. Obviously yours is gonna be perfect and mine will not be. So pretty much after that, his jump, mine's obviously not accurate based off of the following of my drawing because of how I drew it. The drawing should be around, oops. I should head around here. Oops. There we go. Oopsies. Make sure yours is perfect, just like how we're fixing ours now. So I'll go here, hits cross. So, therefore, his jump after that is approximately 21 meters. You also might see it using this symbol, 21 meters. Use your equation to determine the exact height of the man after 4.5 seconds. So this is where we have to use our equation that was given. So y equals negative 2x power of 2 plus 8x plus 24. And we're going to plug in some important information. So x is time, and that's 4.5 seconds. So therefore, we're going to plug that into our equation. So negative 2, 4.5 squared plus x, 4.5 plus 24. And now solve. Make sure you're using bed math. So we have negative 40.5 plus 36 plus 24, 19.5. So therefore, the exact height of 19.5 meters after 4.5 seconds. So Gabe says that the differences in the table of values of his reaction would be equal. Do you agree or disagree? Well, that would be incorrect. Disagree. Because this is a quadratic relation, right? And therefore, we know that the first differences are not equal in a quadratic relation. Only the second differences are, so that's why. All right,